Hi everyone, welcome back to the channel. Today I'll be covering quadratics from A-level Maths, Pure Maths 1. In this video we'll be going over completing the square, solving quadratic inequalities, and finding and using discriminant. So first off, in completing the square, essentially this is changing the quadratic equations on the form ax squared plus bx plus c into a form that looks like a bracket x plus or minus h whole square plus or minus k. So by this plus or minus, I mean it will be either plus or minus, and I'll show you later on how exactly we know that. Now the reason why we use it in the latter form or the completed square form is because we can retrieve two types of information from them. The first one is the coordinates of the vertex, and that is given by h and k. The second is the maximum or minimum value. That is given by k. So essentially when we have our parabolas drawn out, this is when x squared has a positive coefficient, and this is when x squared has a negative coefficient. Essentially, these points here are the vertices, also known as vertex, singular. So in the case where the positive coefficient of x squared, this vertex is known to be a minimum value, or a minimum point to be more precise. The y value for this parabola at that vertex is known as the minimum value. Now when x squared has a negative coefficient, this vertex will have the coordinates of h and k, and it will be a maximum point because of the shape of the curve, and it will have a maximum value of whatever the y value is, and that y value will be given by k. Now one thing to note is that when you're taking the coordinates of the vertex, it will be the opposite for h. So for example, in our equation, it's a bracket x plus h whole square plus k. Then our coordinates will be minus h k. So it will be the exact same for k, but the opposite sign for h. And for the maximum or the minimum value, it will be the exact same for k. Now, to break down the steps of how exactly it's done, we'll use an example question. So for the first one, let's take x squared plus 4x plus 1. So every time you have these quadratic equations and you have to make it in completed square form, you should add something and then subtract that something again. Now, what is that something? In this case, it's b upon 2a whole square. Sorry, it's b upon 2 whole square. So in our quadratic equation, a over here is 1, b is 4, and c is 1. So in this case, it will be 4 by 2 whole square. 4 by 2 is 2, 2 square is 4. So we'll add 4 and then we'll also subtract 4. The reason why we're doing this step is because adding that something into our equation and then also subtracting it ensures that our equation will give us the exact same values. There are no real changes that are being made to it. But the reason why we do this anyway is because, as you can see, this over here is now a trinomial, which is a perfect square, and then it can be written as x plus 2 whole square. Now you're left with plus 1 and minus 4, and that gives you minus 3. So this is our completed square form. If we were asked to write the vertex for this, it would be minus 2, minus 3, because we change the sign of h and keep the same sign for k. And in this case, it's going to look something like this, the graph. So our minimum value will be minus 3. Basically, because the minimum value is essentially the y value at the vertex, if you input the x value at the vertex, which is negative 2, into our quadratic equation, we'll end up with negative 3 as our y value. Before moving on to the next question, I will explain how exactly I made the trinomial in that form. So when we have our index is like this. When we expand it, it's a square plus 2ab plus b square. And then if it was a minus b whole square, it's a square minus 2ab plus b square. Notice how the plus or minus in the brackets depends on the plus or minus of 2ab. So in this case, 2ab will be 4x, and it has a plus next to it. That's why when I wrote it in the bracket form, I put a plus there. And now this value over here, the b, depends upon what the b square is. So in this case, b square was 4. That's why I made my b value as 2. For the next question, let's say we're given x squared minus 8x plus 5. I suggest pausing the video and attempting it yourself for this question and the questions ahead. So now to solve this, it would be x squared minus 8x plus something, and the plus 5, and then minus something. So in this case, the something would be b upon 2 whole square. So that's 8 upon 2 whole square. 8 upon 2 is 4, and 4 square is 16. So notice how I didn't bother taking negative 8. The reason why is because if I did this with negative 8 upon 2, I'd get negative 4. But anyway, negative 4 square will give me 16. So it really doesn't matter whether you take the negative sign or not. So I add 16 and then I subtract 16. So now this trinomial can be written as x minus 4 whole square. The reason why is because here our 8x is negative, so I'll put a minus over here, and here our b square is 16, so our b will be 4. Now you're left with plus 5 minus 16, that's minus 11. So in this case, the vertex would be 4 minus 11, and in this case, it would be a minimum value, and that would be minus 11. The reason why it's a minimum value is because the x square has a positive coefficient, so it will be a U-shaped parabola. So the vertex would be here, and the y value would be at a minimum. Now for the next question, let's say we're given minus r squared plus 12r. So far all of our coefficients of x squared have been positive. Whenever we're given a quadratic equation and we want to make it in completed square form, the very first step you should take is to remove any coefficients of x squared or r squared and so on. So instead of having it as negative 1, I'd need it to be positive 1. So essentially I'd be taking the negative outside of the bracket. When I do that, I'm left with r squared minus 12r. Now I have to treat whatever's in the bracket as I would in the previous questions. So it will be r squared minus 12r plus something and then minus something. In this case, something would be b upon 2 whole square. So that's 12 upon 2 whole square. 12 upon 2 is 6. 6 square is 36. So plus 36 and minus 36. This trinomial can then be written as r minus 6 whole square minus 36. Therefore, this can be simplified to r minus 6 whole square plus 36. Now in this case, the vertex would be 6 and 36. The reason why is because it's minus 6 over here, so we take the positive sign of it, or the opposite, which is positive 6, and then the 36 will remain the same. You do not multiply the coefficient outside with what is inside. Now, moving on to the next question. let's say we're given 2x squared minus 12x plus 7. Again, I'd have to take 2 out to make the coefficient of x squared 1. So when I do that, I'm left with x squared minus 6x plus 7 by 2. And now it's b by 2 whole square. B over here is 6 upon 2 whole square. 6 upon 2 is 3. 3 square is 9. So I'd have to do plus 9 and then minus 9. So now this can be written as x minus 3 whole square, and then I'm left with 7 by 2 minus 9. That's minus 11 by 2. Now to simplify this, that will be 2 bracket x minus 3 whole square, and then negative 11 by 2 into 2 is basically minus 11. So in this case, the vertex would be plus 3 and minus 11. Plus 3 because this minus 3 has to be changed to its opposite sign, and then the minus 11 will remain as minus 11. Now we'll be moving on to solving quadratic inequalities. So there are a few rules you should be aware of. The first rule will be when the quadratic equation is less than 0. So normally we're asked to solve this where we'd basically be finding the range of x values where our quadratic equation gives us a y value less than 0. The reason why I say a y value less than 0 is because ax squared plus bx plus c is equal to y, or that exactly is what our quadratic equation is. Whatever x value we input into this equation will give us a corresponding y value. So in this case, they're asking us to find the range of x values that will give us a y value that is less than 0. So if we had our parabola looking something like this, if our quadratic equation was equal to 0, then the x values corresponding to that will be these 2 points over here. So you'd get one small value and one big value. So whenever we used to solve quadratic equations that were equal to 0, essentially we'd be looking for these small and big values using our quadratic formula, minus b plus or minus root of b squared minus 4ac whole upon 2a. However, because we have an inequality, we have to give our x values in ranges. It is not two distinct points. So in this case over here, our quadratic equation should give us a value that is less than 0. In that case, it is the values within this range of x that will give us a y value that is less than 0. So essentially, it's everything between the x values of the small x and the big X. And we can write that inequality as small less than x less than big. This inequality basically means all of the x values that lie between our small value and our big value of x, because those values are the ones that correspond to a y value that is less than 0. Similarly, if instead of just less than 0, if it was less than and equal to 0, our inequality or range of x will be inclusive of the points that will give us a y value of 0. Therefore, I'm doing less than and equal to, because it's also the small value in the big value that will give me a value of 0 or a corresponding y value of 0. Therefore, the range or my answer will be written in this form. If instead I was given ax squared plus bx plus c is greater than 0, this basically means what is the range of the x values that will give me a y value greater than 0. So again, if I draw my curve looking something like this, at these points over here are the values of x that will give me exactly 0, where my quadratic equation would be equal to 0. I'd have a small value and a big value. Now, they're asking us for the values of x that will give us y values greater than 0. You'll realize that it's everything along these parts where y is greater than 0. That means everything between these regions of x gives me a y value greater than 0. Therefore, you can write this range of x as x less than the small value and x greater than the big value. Similarly, if instead it was ax squared plus bx plus c greater than and equal to 0, this basically means we'd also have to include our x values that will give us a value of y that is equal to 0. In that case, we'd write our inequality range for x as less than or equal to small and x as greater than or equal to big. So these are the main concepts you'll be applying when solving inequalities. Let's say, for example, we were given a question of x squared minus x minus 2 greater than 0. So the first step we would have to do is solve for x is equal to 0 to find out what our small value and what our big value is. We can do that using our quadratic formula, where a over here would be 1, b would be minus 1, and c would be minus 2. So when I apply this in the quadratic formula, I should get two values of x. One of them will be 2, the other one will be minus 1. 2 being the big value and minus 1 being the smaller value. Now, because the inequality is greater than 0, my range of answers would be in two parts, where x is less than the small value and x is bigger than the big value. So that would be x less than minus 1 and x greater than 2. Now let's move on to finding and using discriminants. So discriminants are denoted by the symbol capital D most of the time, and you should know that to find a discriminant you'd have to use b squared minus 4ac. So let's say we were given a quadratic equation. I'll draw it out. This is our parabola, and we'd be given a line that intersects at one point, or the line acts as a tangent to the curve. So the way we would find the point where it intercepts is equating the equation of the curve and the equation of the line to each other. Then you get another type of quadratic equation, and then you'd solve that quadratic equation to find the value of x. And when we solve for that quadratic equation, normally we'll be using our quadratic formula, minus b plus or minus root of b squared minus 4ac upon 2a. So in the case where it actually intercepts only at one point, or the line acts as a tangent to the curve, b squared minus 4ac will equal to exactly 0. This is the rule you need to know. The reason why I say b squared minus 4ac is equal to 0 is because if I substituted that into my quadratic equation, essentially I'd have b plus or minus 0 upon 2a. So that's minus b upon 2a. You'll realize that there is only one solution for x when b squared minus 4ac is equal to 0. So whenever you're given a question and you're told that the equation of the line acts as a tangent to the curve, then you'd have to apply the concept that b squared minus 4ac is equal to 0. Or if they tell you that there is exactly one root, then you have to use b squared minus 4ac is equal to 0. Now in another case where let's say the parabola was like this and it intercepts at 2 points. This is true when if we applied in our quadratic formula b squared minus 4ac is greater than 0, as in it is positive, because when it's positive, we'll have root of a positive number, and then they can be two solutions from that, because you'll first add it and then in the second solution you'll subtract it. So you'd get two real roots for the value of x. So whenever you're told in a question that, for example, there are two real roots, that essentially means there are two intercepts, and when you'd be using the discriminant, you'll be using this rule over here, that b squared minus 4ac is greater than 0. It might not make much sense now, but when we apply it in a question, you'll understand what exactly or how exactly we use these properties. If instead the parabola and the line did not intersect, they're told to have imaginary roots. So in this case, b squared minus 4ac is less than 0. The reason why is because it will give you a negative value, and we cannot root a negative value. Therefore, you'd have imaginary roots or no real roots. So whenever you're told that in a situation with a curve and a line that there are no intercepts, or that it only has imaginary roots or no real roots, then you'll be applying b squared minus 4ac is less than 0. So let's try and apply this concept in a question. So in this question over here, we have to find the set of values of k for which this line meets this curve at two distinct points. So if I graph that out, it would look anything like this, where these 2 points are where they meet. In this case, our discriminant would always have a value of b squared minus 4ac greater than 0, because only at when b squared minus 4ac is greater than 0 that we can have two distinct points of intersection with a curve and a line. So how exactly should we approach this question? Well, first off, we'd have to equate both of our equations to each other as they're intersecting. So 2x minus k is equal to x squared plus kx minus 2. That makes x squared plus kx minus 2x minus 2 plus k is equal to 0. So I can simplify this by writing x squared plus x, take it outside, so that's k minus 2, and then we're left with minus 2 plus k is equal to 0. Essentially now a is equal to 1, b is equal to k minus 2, and c is equal to minus 2 plus k. I made it look like a usual quadratic equation. So if we try to apply this in our quadratic formula, we'd be solving for x, which is quite unnecessary because we're asked to find the set of values of k for which these two equations meet and intersect. So in this case, what we should be doing is applying b squared minus 4ac is greater than 0, because there's no other approach we can really take. In this case, b square would be k minus 2 whole square, minus 4 into a over here is 1, and c over here is minus 2 plus k. So this has to be greater than 0. Now we don't have any x values, we only have k values, and we can solve for this by rearranging it and so on. So k minus 2 whole square, this is essentially k squared minus 4k plus 4 minus 4 into minus 2 plus k is greater than 0. So k squared minus 4k plus 4 minus 4 into minus 2 is plus 8, minus 4 into positive k is minus 4k is greater than 0. So that's k squared minus 8k plus 8 plus 4, that's positive 12, is greater than 0. Now this looks like a quadratic equation, and we can use the quadratic formula to solve for k. In this case, a is 1, b is minus 8, and c is 12. So if I apply this in my minus b plus or minus root of b squared minus 4ac whole upon 2a, you will get two values of k. That will be either 2 or 6. Now because this is an inequality which is greater than 0, we'd have to apply the inequality rule we discussed earlier. So because it's greater than, we'd have two parts to our range of k, and that would be k less than the smaller value, in this case that is 2, and k greater than the bigger value. In that case, that is 6. So k greater than 6. So this is our answer for this part of the question. So that is all for this video. If you have any doubts or more questions you'd like us to solve, please leave them in the comment section below. If this video helped, consider liking and subscribing. You can check out our other videos in our playlist. So I'll see you in the next video. Thank you.